So today we'll talk about the concept called Helm. Okay, so this is not an Kubernetes object, but it's out of Kubernetes. But this is very important topic we need to know in real time to deploy the applications on Kubernetes cluster. So does anyone have idea about what is Helm?
No.
Okay, so here,
Praveen, one thing,
yeah,
will you be covering secrets?
that we will discuss tomorrow. Secret
Fine, fine. Okay.
in it, the small topics we'll discuss tomorrow. Okay, so here assume we have a cluster, whether it may be on premises or whether it may be managed service. If the managed service there, then we don't see any master server, and if it is a QBDM concept bare metal or COPS, then we see master server. So whenever we are deploying an application, assume your project, whichever project you are working, so that project might having, let's say, some 15 microservices. Basically, will have lot of microservices because your big component of your application will be divided into small applications as a microservice. So on an average, if you're taking 15 microservices for an example, so each microservice we are going to deploy. So in GitHub or Bitbucket, for each microservice, the application code will be in each different repository in the source code management. So developers will clone that repository and they'll do modification to that specific repository. And that repository, that application is going to be created as an var file, and that will be converted into the Docker image. And the Docker image is going to be deployed into the cluster. Okay, that is what we will do in the real time. So now, whenever each microservice need to be deployed, it may be expecting lot of components, Kubernetes components should be created. Okay, so to deploy the application, we use deployment .yaml file. We already discussed about different types of deployments, a stateful set, uh, replica set, and deployment daemon set. But mostly 90% for our applications, we use the kind is deployment, because in that deployment we have different facilities like rolling update, blue green deployment, canary deployment. Okay, different options to upgrade your applications. For specific kind of reason only we use daemon set. We already discussed the daemon set means your pod will go and create in each and every work not compulsory. That will do it for only any log aggregation, elk or Prometheus. For those only we use daemon set. So 95% for our applications we use deployment kind only. So that will be, we can name anything. So mostly it will be deployment.yaml file. So here not only this deployment.yaml file, we may need some other resources to run these applications. As I said yesterday, it may need config map for having the properties, or it may also contain secret also to store the credentials. Remaining all the fields might be available inside the config map, but credentials we can store, create inside the secret. And we'll use another object called image pull secret. Tomorrow also just remind me about this. I'll explain about image pull secret. So the concept of image pull secret is we are defining in the deployment.yaml file about the image to pull from artifactory. So this cluster need to have access to the repository, then only it can pull the image. So for that purpose we'll create image pull secret with credentials of artifactory. Like in the Docker, when we are practicing how we used Docker login and then we provided the Docker up credentials, Then only from the Docker machine I can able to connect to the Docker hub. Same way, cluster should able to access the artifactory. So this is an artifactory. So from this artifactory, cluster should connect and it should pull the images. So for that, we'll create image pull secret. Tomorrow I'll show you. It's a single command we can create image pull secret. So this is the one we will create. So lot of other components, like for example, auto scaling you want to do. Obviously, for production environment, we want to configure auto scaling our pod. Means initially we might create with for high availability. See, fault tolerance and high availability is very much important. So for high availability, we'll mention three replicas inside the deployment.yaml file. So three will be get created. But in future, due to heavy load on those three, then what is going to happen? It should auto scale. Instead of three, it should extend to 4, 5. So we want to auto scale. For that, we have a concept called HPA. We need another configuration file. Okay. So horizontal pod autoscaler, we call it as. So for this one, we will configure, and the service, whether cluster IP or whether it's a node port or whether it's a load balancer, how we can access this specific pod, whether this specific microservice need to be accessed from the external world or maybe internally. Based on that, we'll configure service. So it will be load balancer or anything, depends upon the requirement. So like this, multiple objects of Kubernetes are required to run a single microservice. So the same thing mostly we'll use it for remaining microservice also, right? So this it may require for another microservice. For every 15 microservice, for every microservice, we might need this one. Depends. Mostly these are common. Okay. Image pull secret is common to pull the image of the specific microservice. All the 15 microservice images will be here. So to pull that, it will use this one, and every microservice need horizontal pod autoscaler, and every microservice need a service to access. Apart from that, it depends on this applications, it may expect some other components also. Okay, Kubernetes having a lot of components, it may expect some other component. So how we are going to create all these things? So manually we are going to create, right? So as of now, whatever we practice, first of all, if it is a deployment, then what you are going to do? You are going to use kubectl create the YAML file, create -f and the deployment.yaml file. Same way we are going to create all components manually. Okay, so in real time we don't do this way, we use Helm charts. Okay, so what is this Helm? Helm is a package manager for only Kubernetes. Okay, so if you go to helm.sh website, this is a website name. So there itself we can see the headlines, the package manager for Kubernetes. So Helm is the best way to find, share, and use software built for Kubernetes. Specifically, this is for the Kubernetes as a package manager. So Helm helps you manage Kubernetes applications. So Helm charts help you define, install, and upgrade even the most complex Kubernetes applications. So here, lot of advantages on this Helm. So today the complete session will be what is the purpose of Helm, how we can create it, and how we can deploy, what are the advantages, all these things we'll discuss. So if we take an example, let's say in the Linux, I hope most of you guys are aware about Linux operating system. In Linux, RHL5, before RHL5, till RHL4, how we used to install the packages, does anyone have idea? Anyone from the Linux background? to install a software package in the Linux operating system before RHL5. So how we used to install?
RPM.
Yes. So we are using RPM command to install a package, any software package. If it is a Linux machine, and if I want to install any package, then I need to manually download that package inside this machine, and I need to execute rpm-ivh and the package name. But due to lot of dependency issues, because this package will expect some other package, rpm package should be available inside this machine, then it will fail. It will fail stating that due to dependency of this package, it cannot able to install. Then again manually we need to download that specific package and place it in this machine, and then first I install that specific package, and then again we'll come back to this package. But when I'm trying to install the second package, again it might also fail by expecting some other dependency. So like this, it may go up to 5, 10, 15 also sometimes, the dependency issue. So there was a lot of headache for the administrators during that time. Then RHL introduced a concept called Yellow Dog Update Manager. So introduced, so what will do, it's a package manager for RHL. Same way we can see apt get for Debian and Ubuntu. And if you see, Python is also having their own package manager called pip, and for Windows we have a package manager called Chocolatey. So these are the package managers. So what will do, so whenever, so we are going to have a configuration file inside this etc yum.repos.d. Inside that we'll have one configuration file, some abc.repo. So inside this file we'll define one URL where everything will be available, all the packages. Let's say if you have a Red Hat operating system, Red Hat related repositories will be available inside this location by default when you install the operating system. So when I type yum install some package name, http package name, then it will connect to this repository. In this repo, the URLs will be there, the central repositories. So it will connect to the repository, and from there it will download the package. So if the packages are not available here, then you cannot able to install the package. Mostly OS related softwares you are going to get it here. So if you want to install Jenkins with yum command, you will not get in the default repository of the operating system. So Jenkins is providing some separate repository. Then you need to configure that repository inside your this location yum.repos.d. Then whenever you install yum install Jenkins, it will connect to this one and it will install. So this is easy for administrator, right? Same way here also, this is an package manager. Okay, so you can create a Helm chart, and that Helm chart you can store in the some central location, Helm repos, and from there you can able to deploy your applications. So here what we are going to do, we'll create Helm charts. Helm create, give any name, your microservice name or application name. Chart will be created, configure it, and then make it as a package, and that package we can store it in the some remote repository. Okay, so in the cloud also we have a concept called ACR GCR, right? The repositories. So there not only the Docker images, we can even store the Helm charts also. So the chart will be zipped, it's like a tar file, and that tar file will be stored inside the, we call it as an Helm repo. Okay, we can store it there because whenever we are doing modification to the chart, it will changing the version. So it's like in Git, how it is maintaining the version control. Same way here, the Helm repo will also maintain the versions of your chart. So whenever you want to deploy specific version of chart on Kubernetes cluster, then we can use specific version of chart. Okay, so that is how we configure. So first, let me power on my machines so that we can create it. So now we talk about architecture, Helm architecture. Now, how it will be the Helm architecture? So this will be the client and this will be the server side component. So Helm will be installed on any of the client machine. So this client machine can be your local laptop or it can be any virtual machine, any Linux virtual machine also it can be, or it can be your local laptop also, client. So here we'll install Helm software. We'll get Helm software in different ways. For Mac also we'll get, for Windows, for Linux, all the flavors we'll get Helm client package. We'll install here. And a server side component, there will be a component called Tiller. Basically, Helm is having two versions. Okay, Helm 2 and 3. So as of now, we are discussing 2. After discussing everything practical, maybe later on I'll explain you about 3. The difference is 3. For 3, there is a no component of Tiller component on the cluster side, means Kubernetes cluster side. So first we'll discuss 2 because not sure in your organization whether still they are using 2 or 3. So let's discuss both 2 and 3. Okay. So the architecture will be, we need one Helm software. Helm software should be installed in some location. So as I said, this can be your laptop or MacBook or maybe any virtual machine. And the Tiller component will be inside your cluster. So whenever you install any package from here, we can execute Helm command. So Helm install the package name, then it will go and install this package inside this cluster. So whenever we are executing this, it will go and talk to this tiller and tiller will do your deployment. Whatever you are trying to deploy the application, the tiller will take care, and from this component, server side component, it will deploy the applications. But how come this client machines knows that we have a cluster and it should go and communicate to this tiller? So to do that, like how we are able to execute kubectl command from my local machine or maybe from other machine. We need to copy the, if you remember, etc kubernetes admin.conf file. So if you remember this file, to execute the kubectl commands, we copied this file to our local machine so that we can able to access the cluster. From wherever you want to access the cluster, then you should copy this admin.conf file into this local. So let's say this is one Linux machine. So log into any user account, whether it may be root or any normal user account. Inside that, okay, home. So here we'll create .cube directory and we'll copy this admin.conf file as a config file over here. From this user account, this Helm can able to execute. Okay, so use the same user account to initialize this Helm also. Means when you install that Helm package, assume this is some normal user account. In the same user account also you are going to install this package. So then this Helm is going to talk to this cluster. That is how it will talk to the cluster. And whenever you execute this Helm install package name, it will go and talk to the cluster and it will deploy the applications. So Helm is having lot of commands. You can use Helm upgrade and the package name, because if you modified anything inside your Helm chart, then again you can use Helm upgrade, so that what are the changes you have done in the Helm chart, that will be upgraded. Okay, so I created a document for this, how to configure in real time. This client machine will be your Jenkins server. Okay, so we create a Jenkins server. Inside this Jenkins server, we'll configure this, we'll install this Helm package, and we copy this config file inside this Jenkins server. Why? Because whenever I trigger cd job, my Jenkins server should deploy the application on the cluster. That we'll discuss in the coming sessions when we trying to deploy the real-time application on the cluster. At that time I will show you how we will deploy the applications with the Helm charts. Okay, so for that purpose, what I'm going to do, I'm going to create one Jenkins server, and inside the Jenkins server I'm going to install Helm package, and I'm going to copy this config file from this cluster so that I can use this machine as a client machine. Okay, or else no need of Jenkins. Just as of now for today's session, you can take any Linux machine. From there also you can able to do that. Okay, later on we'll configure Jenkins instead of wasting time to configure Java, Jenkins software, all the prerequisites, because anyhow we are not going to build anything. So that's why I'm going to take one Linux machine which will be in the same network so that they can able to communicate. Okay, always remember they should be in the same network, should be able to communicate. Okay, so lot of commands are there. We'll discuss one by one of Helm command, each and every command, how to configure that. So now, as of now, what I'm going to do, I'm going to take one more Linux machine to install Helm. Which one would be better? Let me take this one. So it is coming online, and GitHub. This is this. I hope you guys have. I might use two GitHub accounts. Okay, so one is init6 tech and another one is this one, so you can use this one. So repositories, docs, If you see Helm tiller configuration, installing Helm on Jenkins server, basically it can be any server as of now today. So we use this document for in future classes. Okay, when we try to deploy the application through Jenkins, means whenever I trigger CD job, how the applications will go and deploy in the Kubernetes cluster. For that, at that time we'll use Jenkins. As of now, we use any normal Linux machine. Okay, so this is a command. First, we'll download this from the internet and we'll give permission, and then we'll execute this one, the version, and from the cluster side, we should able to create this service account, cluster role binding. These are some components. We have separate session for this. We call this RBAC, role based access control. So the tiller means, what is this? RBAC means what? We are giving a user to authorize on cluster to access the cluster completely, like permissions. For example, the difference between root user and normal user. Normal user doesn't have full permissions, but we can give permissions by adding into the sudoers file or by giving some specific commands also, right? We can give some specific commands to execute something which normal user cannot do instead of giving full access. Same way in the cluster also we'll create an account and we can give access on cluster. What kind of objects we can give access? For example, I can create a user account and I can give access to specific namespace. So that user can only access the resources of specific namespace, or I will give access to see only deployments. Apart from that, the user cannot able to see some other deployment like services, horizontal pod autoscalers, config maps. This he cannot able to see, that user. So that way we can create. So here also we are creating a tiller user, and for that user we are creating a roles. Okay, service account, cluster role binding, because here tiller is taking care of deployment. So it should have the authority to access the permission to cluster. So that's why we are creating these two steps. Okay, and then copying the cube file, and then we are executing this one, helm init hyphen service hyphen account tiller. Okay, this command we need to execute. These are the few commands. So if already Jenkins is installed, then these steps we need to follow if you already installed. So to have Jenkins, what you need, you need to have Java 1.8, and another thing is install Jenkins. So I'll do one thing, I'll install Jenkins, and I'll install Java, and then I will follow this process. Okay, but a lot of other things also required. If you see in the in future classes, for future classes we need many things. Jenkins server setup, if you see, Maven, Git, Docker, all these things are required. But as of now, for Helm tiller configuration, even it not required Jenkins also. You take any user account. In that user account, you just download this, and from the cluster side, create these components, and in that user copy this cube file and execute this. Okay, so I'm not going to install Jenkins as of now instead of confusion. So now let me log into this Linux machine. Hmm. So I'm going to take this machine. So as a root itself, I'm going to use, I'm executing these commands. So what I can do here, So this one from internet, I'm downloading this. It's downloaded. This is the script, and changing the permissions. See, for you, whenever you want to install, you can use Helm website also to download the packages. There you'll get multiple options in different machines how to install Helm. So here in the documentation also you'll get it. If it is Mac, see this way also you can use it. Desired version you can download and tar extract it and move that command to US local bin so that you can able to execute. And this is what I am doing right now. Curl command, change mode, and here if you see extra option I have giving this one. Why? Because sometimes in real time you need to go with specific version. Otherwise, maybe if you do this one, if you execute this command, it will install the latest version of Helm. So sometimes the latest version might not work properly with your Kubernetes cluster. So which version of Kubernetes cluster you are using, based on that you need to check the compatible version of Helm. So I always prefer two steps, okay, two versions older, okay, from the current version. So that's why I'm using here specific 2.14.1. Okay, so that way you need to check. Okay, otherwise it will install the latest one. And this is for Mac. Brio install Helm, it will install. And this is Chocolatey for Windows. Choco install Kubernetes 7 Helm, it will install. And this is for Debian and Ubuntu. And pip will also available, I think so. Okay. So now what I'm going to do, I will execute this one. It's installed. Now if you type Helm, the command is available. Okay. So this is completed. Now in the cluster side, you need to configure this one. Okay. So I already executed these commands because this is an old cluster. So we can already able to see that. So kubectl get service account grep-i tiller. Okay, it will be inside the cube -n cube -system namespace. So tiller account was already created 45 days ago. So if you want, we can delete all these components. We can create it. Cluster role binding and cluster role and cluster admin. We can delete all these things and we can again recreate. So I'm not going to delete it. Just you need to execute blindly these two commands. So one is creating service account and other is creating these roles, and that roles are binding with this service account. So the tiller is going to have full authority on the cluster because it needs to deploy applications. So whatever the resources you are defining inside the Helm chart, everything it should be created. So that's why it should have full access, like how we give sudo access. Same way here also, for tiller we are giving full authority. Okay, so you can execute these two commands in your cluster. And now We are copying this config file inside this Linux machines. Whatever the Linux machine I have right now, this one here I'm going to copy it. So here cat etc. So this is the file, and before that we need to create a directory called cube. So let me create a directory. Already it was available, and let me go inside this dot cube. So nothing found. I need to copy this content. Vi config, and inside this paste. If you want to execute kubectl commands from here, then you need to install kubectl package also over here, so that you can able to execute kubectl commands from here also. Kubectl get pods, nodes, everything you can do it from here. If you have kubectl, I think it should be there. Yes, kubectl is there. So kubectl get pods -n and cube -system. It's showing the pods from this Linux machine. So this kubectl can be executed from anywhere. Only two things you require. You need to install kubectl package, and the admin.conf file should be copied. It can be any virtual machine, it can be your local machine, anywhere. You can do this kubectl command. You can able to execute. No need to be always to connect to the cluster master. So here it has been copied. Now in this machine, so I need to execute one command. This command. So when I execute this command, what it will do, it will go and do one deployment. If you see here, kubectl get pods -n cube -system. Can you see the tiller deploy? So whenever we execute this command, helm init, so this is going to be created. Kubectl get deployment -n cube -system. So what this command is doing, whenever we execute this command, it is creating a deployment in the cluster, connecting to the cluster and deploying, and it's creating one pod. So this pod will take care of all the deployments. Whenever you do it from the helm from here, so here tiller pod is going to take care of deploying the applications. So whenever you do any deployments from here, it will go to the tiller component. That pod will take care of deploying the applications inside this cluster. If any problem with this tiller pod, then you cannot deploy the applications to the cluster. So always it should be up and running. Okay. So now I'm in this Linux machine. So I'm going
Praveen,
to create. Yep.
yeah, will it create a service also?
Mm-hmm.
Will it create service as well? When we,
What service?
I mean IP, the IP, I mean it doesn't change.
I did not get you. Which service you are talking about, and what you are asking means, will it create means
Uh,
who will create?
Helm.
Tiller?
When, yeah, I mean this Helm complete structure. Will it create that service?
Hmm.
Service in the sense the IP which doesn't change. Even if the pod dies,
Hmm.
and when the new pod gets
For
created,
which pod you are talking? For tiller pod or any
ML,
application pods?
I mean the worker node, the pods which are created here on this worker node side. So that not tiller. I mean the application pod I'm asking.
Okay. So can you please come again? If the application pods are get created, so what you are expecting to create by Helm? Hello?
I mean even in case if the if the pods die, okay.
Hmm.
So new pod will be created. It is taken care by Kubernetes, okay. And the IP
Yeah.
will not change because we have configured service here, right? We have configured the
Yes.
service. IP won't change. So I'm
Hmm.
asking, will this Helm also help in creating that service also?
You mean to say cluster IP or load balancer or node port service is it going to create? Are you asking this?
Yeah, just a service, not a cluster. I'm asking just service.
Yeah, in the previous session when I talked about service means what? It can be cluster IP, load balancer or node port. It depends
Yeah, I
upon
know.
that microservice, which service it required, whether cluster IP to internally communicate or it need to be communicate through the external, then it need load balancer. This need to be configured. So as I said, Helm can create anything, any object of Kubernetes, it can be created. So only thing what we are doing, we are placing that particular YAML file inside the chart. So as I said here, uh, here if you see this is the service. So any object you are putting that file inside the chart. So this all together is calling as a chart here. So service.yaml file is nothing but it's an service only. It's up to you what you configure there, whether it's a load balancer, node port, or cluster IP, whatever the service you configure for this service. So it will be configured all together is combined is called as a chart. So any
Okay,
object
got
you
it.
want to create, so put all those things for that whatever the dependencies is having one microservice to run, what are the components it's required. So we are going to have all those components related stuff as an YAML file. So every YAML file will be inside this chart. Okay. So when you execute this chart, all together will go and created, and when you delete this chart, all together will be deleted, all the components. Okay.
Okay, understood.
Let's say you
Thank
want
you.
to create namespace first. In that namespace, you want to deploy the applications. So that namespace related YAML file also you can define here, and it will create namespace, and inside that these objects are going to be created. Okay.
Okay.
So when I type Helm repo list, it is saying I did not initialize it. So I need to initialize. So what I'm going to do, I'll execute this final command. We'll see. Yes, it's done. Tiller is already installed in the cluster. Okay. So let me see whether, so it's saying already Tiller component is already there. So that's why it is not creating. So otherwise it will create the component. So now if I type Helm repo list, if you see Helm repo list, it is showing the stable repository. So by default, how the Red Hat operating system guys are providing one default repository. Let's say for example, right now I'm using cat etc. This is Amazon Linux image. So when I create Amazon Linux instance, by default, if you see in the etc yum.repos here, we can see these repositories by default. Some repositories are available. So here, whenever I'm typing any package of operating system to install, it will connect to this repositories and it will try to download. If I go with this main.repo, so these are the URLs. It will go and connect to this and it will try to pull that software and it will download here. Same way, when I configure Helm here, Helm repo list, it is showing by default repository. Kubernetes-charts means Kubernetes is giving you lot of default Helm charts. So those Helm charts you can able to use to deploy your applications, not applications, your microservices, but your, for example, um, EFK is there, Elasticsearch Fluentd Kibana. You want to configure this. How we are going to do that? Manually, you need to write a YAML file for everything like deployment type, replicas, where is the image of that Elasticsearch, and how much CPU you want to allocate, how much RAM, all these things you need to write it, but no need. You are going to get lot of default Helm charts, predefined Helm charts, which you can use blindly in your organization. Okay, but not for your microservices. For your microservices, you are going to write your Helm chart, customized Helm chart. But there are some stable Helm charts are available, which is providing by the Kubernetes, and from there you can get, but for example, RabbitMQ you want to configure, messaging queue, and MySQL or Jenkins and Prometheus, Grafana. For all this, you have a default Helm charts are available. That is called, name is called stable. So let me take you to that Helm charts now. Prometheus Helm chart. If you see a stable Prometheus in the GitHub, you are going to get all these Helm charts. So if I go here, you see here Helm charts, tree master stable. So this is what it will connect. If I search Helm, search Prometheus, like yum search command, this is also Helm search Prometheus. So it is connecting to this table, means this one, this one, and it is showing in Prometheus we have different types of requirements are there, but if you want to configure Prometheus, we use this one. Prometheus is a monitoring system and time series database. Okay, this is our chart which is required. Helm search Jenkins, it is connecting the default repository, only single Helm chart is there, and the chart version and the latest open source continuous integration server. So here if you see, I think this will be taking a lengthy session. Tomorrow also I think we need to continue with this Helm, because half of the concept is completed as of now. So if you see here, this is how Helm chart looks like, and if you see the templates directory, here you can see all these different types of directories again. It looks like very lengthy, huge repository. So instead of that, to easily understand, we'll go for EFK. Templates. So not only the stable version, sometimes we may use some other third party, some other guy. For example, even I'm good at some topics. So sometimes blindly we cannot use the Helm charts which are providing the stable. We need to do a little bit of modification. So sometimes what I'll do those modification and I'll put that Helm chart in my public repository. So if you guys want, you can able to also download like that. So many other people will modify that Helm chart and they will place in their public repository. Those things will also will be available here. Like this guy is providing EFK. Okay. So what I'll do, I'll go one step back here. I deleted Prometheus. So we can able to see all these Helm charts, Artifactory, and where the no names are mm, Elastic Stack, Elasticsearch Curator. This is Elasticsearch. Okay, if you see here, Elasticsearch, these are the files. Means these many, I was telling you, right? These are the components. So here for Elasticsearch, these many components are getting created. Deployment, ingress controller, service account, config map, not sure what is this PDB, service account is getting created, and one stateful set also is getting deployed. Even in Kubernetes, we have a concept called job. So these many components are getting created, role binding role. So like I was showing you here, cluster role binding. These also we can define inside a Helm charts. So that will also get created. So all these components are getting created. Okay. So tomorrow what we'll do, where I will create an Helm chart and we need to know the directory structure. So as of now, what I'll do, these are the Helm charts which are some application purpose like Prometheus, Grafana, Elasticsearch, MySQL, Jenkins, okay, Fluentd, see Grafana is there. Some other applications, Heapster, is a metric server. So in this purpose, we'll use this predefined Helm charts, which are providing by the Kubernetes. This is also some important InfluxDB. Where is Jenkins? So Jenkins. So if you go to the Jenkins, here predefined Helm charts, what are the requirements will be there? Everything they are providing. We can use it. See for Jenkins, these many components are getting created. Secrets, master slave configuration. So this is master. Okay. If the volume is required, then it will create volumes also. Network, ingress controller. All this has been configured. So everything gets created. But we, for our applications, we need to create our own Helm charts because you know what is required for your microservice. These are some predefined based upon the Jenkins, they are configured whatever is required. But for our microservices, application microservices, we are going to configure our own Helm charts. How it will be? So the first, for example, for the first microservice, I'm going to create Helm chart. Then what I'm going to do, in whichever directory you want to create, let's say mk directory, uh, my charts. So cd my charts, Helm, create your microservice name. You can give abcd. Okay, this is the chart name. Got created. One directory created. If you go inside the directory structure will be there. So if you, this is the structure. Okay, directory structure. So we need to understand this directory structure. Okay, so what I'll do tomorrow, I'll explain this directory structure, and I will show you from sitting here how to install application on the Kubernetes cluster. We'll discuss. So for as of now, you don't create any Jenkins server. Okay, don't install anything. Only thing you need to do is 3 steps. This one. Okay, first step, and execute these 2 commands on the cluster, and then this is also not required. I'll do one thing. This is the step, and because later on we'll discuss about Jenkins. No, we don't need to waste time to, because we are not using Jenkins in this today's session or maybe tomorrow. And this you need to do for any of the user, whether it's a root or so this can be either root or any home user. It's up to you. If it is a root, then not required to change any permissions. Okay, and then execute this command. These are the 4 steps you need to do. Okay, so this way you need to do. You can see lot of latest versions also. If you want to try with latest version, you can try 2.16, 2.17 is also there, so you can try with latest version also. So when you execute this command successfully, it should able to connect to the cluster. See, this should not get any error when you execute this command. Successfully it should connect to the cluster, and it should able to create tiller deployment here.